Okay, I think we'll move on and introduce our second speaker, Tom Kutcher. Tom is a wetland scientist for the Rhode Island Natural History Survey, housed at the University of Rhode Island. His work focuses on the development of rapid and biological wetland assessment methods and the advancement of wetland conservation and restoration programming for the state of Rhode Island. Take it away, Tom.
Thanks, Kathy. Can you see me and hear me okay?
Yes.
Great. Okay, hi everyone. I'm going to talk a little bit about how to use a salt marsh rapid assessment method to help guide salt marsh management and how we have started to do that in Rhode Island. I think there's been some questions about, well, what if we don't have data for some of these models? And we ran into that same thing. So this is a way to rapidly collect data that can help with prioritization. And I think it's worth mentioning that the work I'm presenting here is funded by a EPA Wetland Program Development Grant. So thank you, EPA. So this work is part of the Salt Marsh Restoration Assessment and Monitoring Program, something that we call RAMP. And Courtney Schmidt will talk a little bit more about that later today. We have some guiding documents, and we have a salt marsh monitoring and assessment document, a restoration strategy, a framework for prioritization, and this work really spans all three. More specifically, it addresses the objectives to develop restoration and intervention prioritization tools, and to prioritize coastal wetlands for restoration and migration. So although this pursues systematic statewide prioritization, it also can provide information for stakeholder-driven prioritization. So just to clarify what rapid assessment is, so I think we're all really familiar with landscape level assessment. I think most of the presentations yesterday and today have dealt with landscape level assessment, creating models such as the SLAM model here by Kevin Ruddock. And I think everyone's pretty familiar with intensive assessment, which here's Dr. Kenny Raposa, my friend and colleague, doing a sediment elevation table on Prudence Island. And that deals with intensive measurements of biological and physical parameters at limited few sites, right? And each one is extremely valuable, but they have their limitations. So for example, landscape level assessment isn't always reliable at the site level, particularly maybe for elevation data, but certainly not for some other, data that you can only see on the ground. And intensive assessment, although it is very reliable at the site level, because it's only done at a few sites, because it's so intensive, it takes so much time, it has to be inferred across other marshes. So we can't use that for prioritization. Of course, it supplies all the information for the rapid assessment. I mean, we've used a lot of the information that Kenny found, just like Caitlin showed in one of her slides, to inform the rapid assessment. But now the rapid assessment takes data from observation, estimation, rapid measurements, across multiple parameters, and it's reliable, coarse, but reliable at the site level, and it takes about a day to do each marsh, so it can be done across multiple marshes, so we can compare marshes to each other, which is important for prioritization. So here's what the salt marsh rapid assessment method looked like. We call it MarshRAM. I wish I would have thought of WATCH, like Leanne's group did, because that's much cooler. And if I was more, I don't know, if I was a little smarter, I would have done that. But nope, it's just MarshRAM. So this builds on a couple of other rapid assessments, the New England rapid assessment method and the Rhode Island salt marsh assessment, but it expands on those and it tries to be more comprehensive. So it looks at characteristics and classification, like you can see here, ecosystem functions and services. It does opportunistic water bird tally, surrounded landscape condition, disturbances. It does a rapid migration metric, or a few of them actually, and an indicator of marsh integrity. And here's a map that we would take out in the field. And it's actually an out in the field process where you have to go get dirty and muddy to do it. So here's our most subjective indicator. It's an ecosystem functions and services. And these are inherently subjective. So of course we have definitions and decision processes that Kate Mulvaney forced me to write down on paper, which is great. Thank you, Kate. So we try to keep this coarse, but to be useful, it has to rank things, right? So we have basically the two main ones: not evidently provided or provided, right? But then sometimes the nuance, well, it just provides it a little, or this is really special importance. So we rank those, each one, we sum them up, and it gives a basic idea of the functions and values. It is what it is. For wetland disturbances, this comes largely from NERAM, although we added a few. And again, we try to keep this really coarse, ditching and draining, and they're defined, right? Impoundment and tidal restriction, coarse but defined. Edge erosion, coarse but defined. So coarse data, but useful data. And then we have this migration potential metric. Yes, we have SLAM in the state, but this metric's a little bit different in that it looks at the marsh specific. What's the marshes, this specific marshes opportunity to migrate, and what area of the marsh without much intervention would migrate naturally, and how would it replace itself without intervention, right? So it looks at slightly different things. We could probably, and we do use the elevation data that we use from SLAM to do this, but we could probably use SLAM data, but I mean, just for a quick look at it, it's just as easy just to do it empirically. And then sort of the central metric is this index of marsh integrity, and I'll talk a little bit more about this one, where we look at, so we use a walking transect approach. So we walk these transects, and every step we walk through one of these pre-assigned salt marsh types counts as a data point. And from that, we estimate the total cover of these pre-assigned salt marsh types. And each one of these salt marsh types has been assigned by myself and Dr. Kenny Raposa and Dr. Kathy Wigan and Dr. Charlie Roman got together and assigned these coefficients based on sensitivity to inundation stress, but also sensitivity to other stresses. And then we take the weighted average, and that gives us an index from 1 to 10 of how sensitive overall or how resilient maybe the marsh is, depending on how you look at it. So a marsh that's dominated by intact meadow high marsh and intact low marsh, which we don't have very much of left in the state, unfortunately, would get a score approaching 10, right? And a marsh that's dominated by what has taken over much of our low marsh, which is we call dieback denuded peat, or Phragmites, would get a much lower score, maybe approaching 0. Here's what it looks like across the first 30 marshes that we looked at. We've done more. We've done about 60 marshes, but it's easier to just look at 30. So here's Sheffield Cove, and if you look at this key here and you laid it on its back, you can see that Sheffield Cove is largely dominated with salt shrub and meadow high marsh, and has very little dieback denuded peat, which we saw in that picture, and die-off bare depression, which Caitlin showed at Ninigret Marsh, right? And it gets a high IMI score. In contrast, Quaney East, which Caitlin was the second marsh that Caitlin showed, had very little salt shrub and meadow high marsh, and was dominated by these die-off bare depressions, dieback denuded peat, and this transitional area, as in Kenny's slides, SA high marsh, which on the high marsh, stunted SA has been shown lately to be a sort of a transition zone between, the good stuff and the bad stuff. All right, so while we're on this slide, now we can think of this as a reference data set, right? So instead of saying, well, Sheffield Cove is our reference target, we can say, no, these are our least degraded sites, and these are our most degraded sites. So if we go out to a site and we do an IMI, we can say, oh, well, look, Sepauwett is among the most degraded sites, or Chase Cove is among our least degraded sites, right? And that starts to give us some information about how we can prioritize. I mean, this is just a first cut, but this is some information, right? So then if we take this upper quartile and this lower quartile and put them into categories, here's that same list, right? Here's Sheffield Cove, here's Quaney East, and we also categorize everything else that's in Marshram, all these other things. We can say, okay, Sheffield Cove is least degraded, It has average functions and services, high migration potential, and, issues are, there's a big erosion issue, and some fill and some ditching, right? If we look at Quantity East, which we recently did the thin layer deposition on, or thin layer placement, most degraded, one of our most degraded sites, above average functions and services, high migration potential, right? And here are the issues, lots of ditching, erosion. So we can now start to really compare sites to each other and all their attributes. So this is basically what someone like Wendley Ferguson, someone who's been to a bunch of sites, would be thinking about in their head, but it just systematizes that process, right? And puts it out in front of everyone so you can see, okay, I'm looking at this and I get a feel for it, right? It's not prioritization, but these data have been useful just the way they are in prioritization. In fact, the U.S. Fish and Wildlife Service Atlantic Coast Ventures used this for Rhode Island for their salt marsh sparrow prioritization models, right? So they're already using this data, which I'm psyched out of my mind about, right? So we took it one step further and we said, okay, how can we use these data to do a systematic, top-down, statewide prioritization? If all our salt marshes are going to drown in place at once, which we expect with sea level rise, which ones are going to be more resilient, and which one, and think about other factors too. And what type of restoration should we do? Should we let it migrate? Should we do restoration? Should we do both? So we actually developed a matrix, and it's based on a systematic process to develop these rankings where a 5 is the highest priority and a 1 is the lowest priority for migration or restoration. And we can put any marsh that we have these data for, we can put into here. So if we go to look at Quantity East again, which is that restoration one, most degraded, right? Most degraded, so low, high value, so a high ecosystem functions and services, and high migration potential. That would be the highest priority for migration and a high priority for restoration, right? Or if we look at still Sheffield Cove, we see that it was high integrity, moderate value, and high migration potential. You say, well, it's a high priority for restoration, but it's a low priority. I mean, high priority for migration, low priority for restoration, because it's already in good shape. There don't seem to be too many stressors on it. It's all spelled out. And then my final slide shows this is what we get: an imperfect but useful list, right? A first cut as a state, and also a way that we can apply for funding and put things in perspective with each other, right? So here's Quantity East. It came out very high, right? This was high for migration, high for other restoration. Here's all the other data, right? And then we look at, what else did we look at? We looked at, where is it? Yeah, Sheffield Cove, right? We said it was high for migration, low for restoration. Here's the information. Anything that either had highest or high migration or highest or high restoration, we sorted at the top here and put in green, right? So again, it's a first cut. It's a lot different than some of the other models that we've seen. It's very basic, right? And this here is just, guidance for these restoration targets. We had these right in here, what restoration should we do on these based on these, but we've gone back and forth on whether we should use this guidance or not. There goes my bird of doom, but I'm already ahead of the game. I'm done. What I can do is I can go beyond my final slide and say, we can also use this to assess restoration outcomes. So this is from a study that Kenny Raposa and I did, where we looked at, here's our reference marshes, right? And here's the upper quartile and the lower quartile with those same rankings of, what the average distribution of salt marsh types were, right? Here's our control average distribution, and here's the restoration marshes we looked at. So we can see, the final outcome of some of these were similar to our most degraded, and some of them were similar to our least degraded marshes, or better than our least degraded marshes, right? And we can look at, well, what were the actions taken? What was successful? What wasn't successful here, and what was, right? So course information, but I think really useful information. And with that, I think I'll go to this slide and say thank you very much to my partners. And if you want more information on the rapid assessment method, it was just published in Ecological Indicators, which is free online to everyone, which I had to pay for, but awesome.
Thank you, Tom, and thank you, Caitlin, for those really interesting talks. And now we have time for the participants to ask questions of Caitlin and Tom. So I'm going to turn it over to Joe, and Joe will facilitate asking the questions.
Yeah, thanks, Kathy, and thanks to both of our speakers for those great presentations. Just a reminder to put a question in the chat if you'd like, put a Q in front of it if it's a question, or a C if it's a comment or some feedback on what you've heard. And if you have a question for a specific speaker, please indicate that. I'm going to turn it right over to Joe now because I think there may already be some questions in the chat. Joe?
Yes, thank you, Joe. So first question for from Rachel for Tom, and that is, for those Marsh integrity transects, did you use transects that were perpendicular to the coastline or transects that were parallel to one another?
Well, yeah, they were perpendicular to the coastline first. So, you know, we generally would like to make them parallel to each other. But for marshes that encircled, say, a pond, we would draw as few sort of guidelines as we could, and then put them perpendicular to those guidelines, right? So in marshes that were circular, we did surround the marsh, and they always went from the upland edge to the water's edge.
And then there was a question from Jordan. I may have missed this, but can you clarify how a place like Quaney can show is most degraded, yet score high for functions and services? Seems counterintuitive.
Yeah, well, so a lot of our functions and services are use, right? So human use. So we take into cultural considerations, aesthetics. Boy, I'd really like to go back. Let me look here. What do we have on here? And why did it score high? So storm protection and property, that wasn't one. Wildlife habitat, hunting and fishing platform, threatened and endangered species habitat, fish and shellfish habitat, carbon storage. So some of these, I'd have to go back and look to see why it scored so high, but you know, certainly it's a highly used recreational platform, a fishing platform. It has high wildlife habitat value. It's certainly is a view shed for many people because there's lots of homes surrounding it. So it came up high for a lot of cultural reasons, right? So we mix things here. You know, to be said, you know, this isn't a goal specific thing. So we treated everything equal, right? So we have habitat values equal, but you know, we did have salt marsh sparrows there probably. We did have, you know, wildlife. We did probably had rare and endangered species. I'd have to look at the data though to know for sure.
Okay, thank you. And here's a question for Caitlin from Jordan. After the Ninigret project, do you feel you've been able to reduce some of the uncertainties that were so challenging?
Yeah, thanks, Jordan. That's $1 million question, right? I would say a tentative yes to that. I think for some things for that kind of site. So I think, you know, doing work on a back barrier marsh in a coastal lagoon is a very specific scenario. So there was another question about sediment. So it's like we were working with sand. I think now after doing 2 of those projects, we know a lot more. I think certainly the improvement of using the RTK enabled equipment to manipulate the material after it was placed really improved our accuracy with like reaching that project design. But I think if we were working in a different type of system, you wouldn't necessarily be able to apply all of those lessons learned. So I'm thinking something farther up the estuary, farther up the bay with finer sediments, you may have different challenges. So, Yes and no. And of course, things like construction costs are changing all the time. And we know right now they're insane, right? So that's always going to be in flux, but we know more of what we didn't know, I guess is probably the short answer. Thanks for that question, though.
Thanks, Caitlin. And just going back to the use of sand, there had been a prior question from Julian, who was asking whether there was a question about the material quality. And I think you confirmed that the sand was considered clean material. Is that right?
Yeah, it was essentially beach sand that was beach material that was over 90% sand, which was beneficial to us because, again, it drained quickly. We didn't have to test for certain contaminants because we didn't have that many fine particles. So it kept our costs down, and we think it worked well as far as, you know, a material that was easy to handle. So
Thank you. A question from Marilyn for Tom. What about the priority for maintaining currently high quality sites? Done only if low migration potential? Need help.
Yeah, we could spend 2 hours on that, right? On that matrix. But yes, so if a site is high quality, I think it basically it bumped it up for restoration potential as well. But if it had low migration potential, it bumped it down for migration priority, right? Because you don't want to, if it really has very little migration potential, you don't want to prioritize that for migration. It might have some, but you might get more bang for your buck. And again, these are preliminary, right? So we would never do a restoration just based on these data, but they're very useful to, like, say, okay, so, you know, we may be adding staff this year. And what will our staff work on? Well, maybe they'll look at these sites and they'll put more effort into assessing these sites for restoration possibilities, right? Further looking into them and, you know, getting them ready for when that next grant comes through, they're ready to go.
Thank you. One more question for you, Tom. Were these assessments done on private or public lands? What audience or user group do you foresee using this type of assessment?
Yeah, so, okay, so let's do questions. One question, the first question is, there are some private salt marshes in Rhode Island. You know, because it's an intertidal zone in Rhode Island, anyone has access to anywhere in the intertidal zone. So that's a constitutional right. So we can access anywhere. Of course, if it was a private one, we would ask permission to go out on there. But no one ever said no. But if they did, I might say I might go out anyway. And the second question was, what was it?
What audience or user group do you foresee using this type of assessment?
Yeah. Okay, so that's a two-part question. So first, it's mainly made for the state, right? For Caitlin and for the RAMP group, who will be, and for Wenley Ferguson, who will be working on these types of projects and who will be wanting to prioritize. And, you know, U.S. Fish and Wildlife, for example. So the professionals, right? But also I found, and I've given lots of presentations with these data, that it's really useful to communicate, you know, those matrix I had to communicate the information about salt marshes and how we might rank them and what's going on with the salt marshes. They're pretty good, you know, easy to figure out, easy to understand sort of ways to look at the data.
Okay, thanks. That's it for the questions in the chat for now.
Okay, great. Well, thank you so much, Caitlin and Tom. Great presentations. Thanks for your remarks in response to the questions. And then we'll turn it back to Kathy.
Thank you.